Hey there, cosmic explorers! Are you ready for a mind-blowing journey? Today, we are going to talk about a concept that sounds like science fiction but is as real as the phone in your hand. Imagine the universe, in its infinite wisdom, has a twisted sense of humor and has created an evil twin for everything. No, I am not talking about your sibling who stole your candy. I am talking about antimatter. Yes, antimatter. Think of it as the perfect reflection in a magical mirror. If you are a particle of normal matter, like an electron, there is your counterpart, an anti-electron, which is also called a positron. This twin is identical in mass but carries the opposite electrical charge. Every atom, every particle, and every tiny bit of what makes you up has its anti-self somewhere in the rules of physics. Now, here comes the exciting and frankly a bit terrifying part. Imagine you could approach this anti-you in the mirror and reach out your hand to greet it. What do you think would happen? Would you shake hands and have a deep conversation about existence? Not at all. At the slightest touch, both you and your anti-self would disappear. Poof! You would simply vanish in a flash of energy. This is no cosmic joke. It is annihilation. When a particle of matter meets its antiparticle, both are instantly converted into pure energy. And not just any energy. The amount of energy released is absolutely mind-boggling. We are talking about a single gram of antimatter colliding with a gram of ordinary matter, potentially releasing energy equivalent to a gigantic nuclear bomb. It is the most efficient way we know in the universe to convert mass into energy. So, if antimatter is so powerful, and if its contact with normal matter is so explosive, why are we not all exploding every second? And where is all this antimatter that, according to the laws of physics, should have existed in equal amounts to matter at the dawn of the universe? Look around you, because everything we see, touch, and are is made of normal matter. Antimatter is either incredibly rare, or it hides very, very well. This is one of the greatest and most fascinating mysteries of the universe, and the key to unraveling it awaits us just on the other side of this explosive reflection. Are you ready to dive into the science that explains this spectacular phenomenon? To understand this explosive mirror, we need to travel back to the most dramatic moment in the history of the universe, the Big Bang. Imagine an instant of unimaginable energy, an infinitely dense and hot point that suddenly expanded at dizzying speeds. In that primordial cosmic furnace, pure energy was so intense that it constantly transformed into pairs of particles and antiparticles. Think of it as a vast cosmic factory working at full throttle, producing twins identical in mass but with opposing personalities. There was a twin of normal matter and its antimatter twin. For every proton born, an antiproton appeared. For every electron, a positron. It was a grand party of creation and annihilation. Because these pairs did not get along, as soon as a matter particle and its antiparticle met, they would boom. Their existence would mutually cancel out in a flash of energy, reversing the process. If the universe had created exactly equal amounts of matter and antimatter, in the blink of an eye, everything would have vanished in a gigantic burst of pure radiation. The universe as we know it, with its twinkling stars, spiraling galaxies, blue planets, and you listening to this, would never have existed. There would only be a vast, empty sea of light. But here we are. Which means that, for some reason that still keeps physicists awake at night, there was a very slight, almost imperceptible excess of matter over antimatter. It is as if, in that gigantic cosmic lottery, for every billion pairs of matter and antimatter that annihilated each other in a spectacular embrace of light, one lonely leftover matter particle remained. That tiny, almost ridiculous, extra fraction of matter is all we see today. You are, literally, one of those lucky cosmic leftovers that survived the Great Purge. We have already talked about antimatter being like a reflection or a mirror, but let us delve a bit deeper to understand its fundamental nature. At the level of the tiniest particles, every type of normal matter particle has a corresponding antiparticle. They are like twin siblings who share the same appearance and mass but have a fundamental intrinsic characteristic inverted. The most notorious and easy to understand is electric charge. An electron, that tiny, negatively charged particle dancing around the nucleus of every atom, has its counterpart called the positron. The positron is identical to the electron in every way, except its electrical charge is positive. Similarly, the proton, which is the positively charged particle residing in the atomic nucleus and giving elements their identity, has its antiproton, which possesses a negative charge. Even neutrons, which are electrically neutral, have antineutrons. Although they do not have an electric charge to invert, they have other internal quantum properties, like their magnetic moment and quark composition, that are effectively inverted in the antineutron. If imagination allowed us, and we had the right components, we could build an anti-atom. For example, antihydrogen would consist of an antiproton at the center, orbited by a positron. The rules of quantum physics tell us that this anti-hydrogen would behave exactly like a normal hydrogen atom. The anti-chemistry of antimatter would be identical to that of matter. If an anti-you made entirely of antimatter existed, you would not be able to distinguish it at first glance, not even by its behavior, until that critical moment when it tried to shake your hand. The reason why the encounter between matter and antimatter is so spectacularly explosive, and not just a silent goodbye, lies in one of the most famous and revolutionary ideas in science. This is Albert Einstein's equation, E equals mc squared. This small but incredibly powerful formula tells us that mass and energy are not separate, immutable entities, but two manifestations of the same thing. They can convert into one another. The factor of c squared, which is the speed of light squared, is a gigantic number. This means that even a small amount of mass contains a brutal amount of energy. When matter and antimatter mutually annihilate, their mass does not disappear without a trace, as if someone had erased it with a cosmic eraser. No, in the annihilation process, 100% of their mass is converted entirely into pure energy. This primarily takes the form of high-energy gamma rays. Imagine the difference compared to everyday life. When we burn wood, only an infinitesimal part of its mass is converted into the energy we feel as heat and see as light. Most of it becomes ash and gases. It is a very, very inefficient conversion of mass to energy. But with matter and antimatter annihilation, it is the maximum possible yield. Every gram of mass transforms into energy. That is why a single gram of antimatter, upon colliding with a gram of ordinary matter, has the potential to release the energy of thousands of tons of dynamite. It is an unimaginably dense energy source, far beyond nuclear fission as seen in atomic bombs or nuclear fusion as seen in the sun. Despite its reputation as an evil twin and its destructive potential, antimatter is not just a theoretical curiosity or a comic book villain. We find it in various places, from the most violent corners of the cosmos to life-saving medical applications. Our planet is constantly bombarded by high-energy particles traveling through space at near-light speeds. These particles, known as cosmic rays, sometimes contain positrons and antiprotons. It is believed that these anti-gems form an extremely energetic astrophysical reactions, such as the collapse of massive stars or the collisions of other particles in the vast interstellar space. They are our natural evidence that antimatter still exists and is forming in the universe. Beyond the stars, we also create it here on Earth. Places like CERN, the European Organization for Nuclear Research on the Franco-Swiss border, are like giant laboratories where scientists recreate the extreme conditions of the early universe. There, by accelerating normal particles to dizzying speeds and smashing them together with tremendous force, they can produce particle and antiparticle pairs. It is like forcing energy to convert into matter and antimatter. Physicists have managed to create and trap tiny amounts of anti-hydrogen, the simplest anti-atom, for increasingly longer periods like minutes. This is an astounding technical achievement and allows us to study its properties with unprecedented detail. Nature is full of surprises, and you might even find antimatter in your own body on a tiny, harmless scale. Yes, you read that right. In our bodies, and indeed in all organic matter, there are natural radioactive isotopes that constantly decay. One of these is potassium-40, which is found in many things we eat and in our own tissues. Some of these decays emit positrons. These newly born positrons immediately encounter one of the trillions of electrons around us, annihilate, and release tiny bursts of energy in the form of gamma rays. But there is nothing to worry about. The amount of antimatter generated is so minuscule that it is completely harmless and goes unnoticed. However, we have found a way to use this same process in modern medicine through positron emission tomography, or PET scans. This is one of the most fascinating and vital applications of antimatter. PET technology is an indispensable medical imaging diagnostic tool. To make it work, a slightly radioactive substance is injected into the patient. This substance is designed to be absorbed by areas of high metabolic activity, like tumors. This substance emits positrons. When these positrons encounter electrons in the body's tissues, they annihilate, emitting pairs of gamma rays that travel in opposite directions. Special detectors capture these rays, and a computer uses them to create detailed images of organ activity or the presence of diseases. It is a brilliant example of how a concept that sounds like science fiction becomes an everyday tool for saving lives and improving health. The biggest puzzle that antimatter presents to scientists is, without a doubt, the matter-antimatter asymmetry. If the laws of physics we know suggest that equal amounts of both should have been created in the Big Bang, where is all the missing antimatter? Did it hide somewhere in the universe? Is there a distant anti-galaxy made entirely of antimatter that we have never detected? Most theories and observations suggest the answer is no. If large accumulations of antimatter existed in the visible universe, we would see gigantic and constant annihilation explosions at the boundaries of these regions as they interact with normal matter. We see no evidence of such large-scale phenomena. This leads us to an almost inevitable conclusion. In the earliest moments of the universe, there must have been some small, yet crucial, asymmetry. There was some subtle imbalance in the fundamental laws of physics that favored the creation of a tiny bit more matter than antimatter. This symmetry violation is an extremely active area of research and is fundamental to understanding why our universe is made of matter and, ultimately, why we exist. It is as if the universe had a slight preference for one of the two twins, and that preference, however minimal, made the difference between a universe full of stars and life, and an empty universe of only light. You are the living proof of that small cosmic imperfection. While the idea of spaceships powered by antimatter annihilation or antimatter weapons sounds like a Hollywood movie, the reality is that producing and storing antimatter is incredibly difficult and incredibly expensive. For now, it is only achieved in minuscule quantities. The challenge is monumental because the slightest particle of normal matter that comes into contact with it would instantly annihilate it. Imagine trying to keep a piece of ice in the desert without it melting, but with the melting being an explosion equivalent to thousands of bombs. Even so, antimatter remains a fascinating field of study. Understanding it thoroughly not only helps us solve the mystery of missing matter in the universe and unravel the secrets of the Big Bang, but it could also open doors to unimaginable new technologies in the future. Who knows? Perhaps one day, the universe's most powerful battery, the densest energy source we can conceive, will be a small gram of carefully contained antimatter. So, the next time you look in the mirror, take a moment to reflect. Beyond your familiar reflection, there exists the concept of an anti-U made of antimatter, with an explosive potential that defies our imagination. It is a fascinating reminder that reality hides depths we are only beginning to explore. And that, sometimes, the greatest and most spectacular mysteries of the cosmos are revealed when we look at the world in reverse. What other surprises await us in the realm of the invisible in our next episode? If you enjoyed this journey into the explosive mirror of reality, don't forget to hit the like button and share your thoughts in the comments. To keep exploring the wonders of our universe with us, make sure to subscribe to the channel and turn on notifications so you never miss a mind-blowing discovery. See you in the next one. For more information, visit minrora.com.